Welcome to my YouTube channel. If you like my videos, press the like button, share it with your friends, and also subscribe to my YouTube channel Physics with RM. In today's video, we will start the new chapter of physics, chapter number 6, which is fluid dynamic. Now we are moving forward and start the chapter number 6, fluid dynamics. What is fluid dynamic? The branch of physics which deals with the fluid in motion is called fluid dynamics. So here the question arises, what is fluid and how we define fluid? Fluid, a substance which can flow, is called fluid. So this is the basic definition of fluid. Now we are moving forward and start the main topic 6.1, viscous drag and Stoke's law. Here we define what is viscosity. Viscosity is actually the internal frictional effect between the different layers of fluid flowing. And viscosity measures how much force is required to slide one layer of the liquid over other. So this is the basic definition of viscosity. Now we are moving forward and see what are the coefficients of viscosity, units of viscosity, dimensions of viscosity. Then we further discuss about the viscous drag force and also Stoke's law. So here first of all we discuss about the coefficient of viscosity. How we represent viscosity? Viscosity is simply represented by eta, eta, and represented by a symbol eta. Dimensions of viscosity, dimensions always represented in a square brackets. So the dimensions of viscosity is mass, length and time. Mass per length per time. So here the units of viscosity, the unit of mass is kilogram, the unit of length is meter. So here per length per meter, and the unit of time is seconds. So here the units are kilogram per meter per second. So this is the units of viscosity, dimensions of viscosity and symbol. Now we are moving forward and see viscous drag force. So when an object moves through a fluid, it experiences a retarding force. For example, when an object is moved through a fluid, any fluid, it experiences a force. Which force? Retarding force. And this force is called a drag force or fluid friction. This force is produced due to friction in the fluid. So this is the definition of viscous drag force. Now we are moving forward and see what is Stoke's law and how we state it. It states that the drag force on a sphere of radius r moving with velocity v through a fluid of viscosity eta and is given by F is equals to 6 pi eta rv. So here viscosity is represented by eta, radius, sphere of radius r, and velocity is represented by v. So Stoke's law, F is equals to 6 pi eta rv. This is a basic Stoke's law. There is one more thing which is more important and you must learn it, that this law holds for small velocity v. For higher speed, drag force is no longer simply proportional to the speed. So it may be force is directly proportional to the square of velocity for higher speed. So this law is satisfied for only the small velocity, which is v. If the velocity is higher, the speed is higher, so drag force is directly proportional to the square of the velocity. So this is the very main concept, that this law is holds for only the small velocity, which is v. So in this video we will cover the first topic 6.1. Then in the next videos we will discuss the next topic step by step. So now here we will see from the book how we prepared this topic. So chapter number 6, fluid dynamics. There is a basic intro of this chapter on this page. Now we will see the next page. From this page we will cover the basic definition of viscosity.